We have seen how to integrate the UI, optimization engine, and data checker to gather feedback from the end user. This process, parallel development, integration, and feedback, is iterative. We'll repeat several times until we get to a satisfying application that we will want to deploy on a separate server. The deployment of a full application can be tricky. It usually takes time and requires specific skills. The platform performs functions to support this phase and makes it as simple as possible, thanks to modern technologies like Docker and Kubernetes. All the services generated with your application can be encapsulated as Docker images. We provide all the configuration files to do this. The only thing you have to do is to run the Gradle command, Gradle Docker. This will create a Docker image for each of your services: the gateway, the authentication service, the web user interface, the backend, the execution service, the scenario service, the data service, all the databases, and the optimization server and its workers. The optimization server is actually already packaged as Docker images that are coming from our Docker repository. In the Gradle template folder, you can find the default definition of all the Docker images. It is built from a public Docker image and includes the project jar file, which is run when the Docker container starts. A specific Docker file is available to build the web front-end user interface. It can be found in the web front-end service. The Docker image is built on top of an nginx image, into which we copy and configure the different parts required to run the front end. You may need to customize the Docker files, for example for the engine worker, on top of the default information that we store in all Docker images. We need a copy of a Cplex distribution. This is just an example. The customization depends on how your Cplex environment is organized on your laptop. To create or update all your application Docker images, you just need to run the Gradle Docker command from the top of your application folders. You can, of course, create a Docker image for a specific service. To achieve this, you go to this service folder. So, for example, the gateway server, and then you call the Gradle Docker command. Creating Docker an image is very fast, meaning that deployment of all your changes will be seamless. During the development, there is a need to run the different services as local processes, usually from the IDE, so you can set up some breaking points and debug them. Another strategy is to rely on Docker Compose to describe how your different Docker files should be run, and have a part run with Docker Compose and a part run with local processes. Let's have a quick look at the Docker Compose files that have been generated in your project. The Docker Compose file can be found in the deployment Docker folders that were generated. We can find a Docker Compose to start the different infrastructure services, the different databases that you require, and the RabbitMQ communication service. We can find a second predefined Docker Compose to start the optimization server. And finally, a third Docker Compose is available to run the application-specific services. Those Docker Compose files are ready to be used and do not usually require any configuration. Finally, when you want to move to production, you will want to rely on more production-oriented systems like Kubernetes or OpenShift, where you have more flexibility on the way you manage the elasticity of the application, the number of workers, the ways to increment, to add, or renew workers based on demand. Such systems also increase the robustness of your production environment, allowing you to monitor what's happening and to restart automatically part of your services if for any reason they go down. When we say that the generated application is cloud-ready, what we mean is that it will be very easy to deploy to systems supporting Docker technology, whether you target a simple environment like a unique laptop or whether you target multiple server environments like Kubernetes and OpenShift. What you should keep in mind here is that the Docker technology will allow you a lot of flexibility and a lot of comfort in the environment that you target when deploying your application. You will not have to spend time validating that your deployment environment has the proper operating system and the proper libraries, and As a consequence, you will not spend time debugging installation-related issues.